a multi-agent system using Llama Agents. 5 plus 3 is equal to 8, 8 plus 2 is equal to 10, and then it got the answer back from the calculator. We're going to use two different models, one Mistral, the second one is Arcee Agent. Arcee Agent is supposedly good for function calling, so we're going to use Arcee Agent and Mistral to use two tools. One is a calculator tool, the second one is a natural language processing tool. So to be honest, this is not a 100% perfect solution at this point, but the main thing that I wanted to highlight in this video is how you can completely run this model locally. You don't need any paid API like GPT-4 or Claude, and you can run this on your local machine if you've got a decent enough machine. I mean, decent enough machine is subjective, but let's say that if you have got a computer without a dedicated NVIDIA GPU, this code will exactly work just like how you would see in this YouTube tutorial. I will link the code in the YouTube description so that you don't have to struggle. And this code has a lot of different moving parts. So if you're not familiar with some of the items, I would strongly encourage you to let me know so that I can branch into the further direction in the future tutorials. To start with, let me quickly show you a demo because I was mind blown when I got to know that this actually works. First of all, I have gone to this agent and I said one simple question. What is 5 plus 3 plus 2? And I've got two agents. One is an NLP agent. The second one is a calculator agent. And as you can see here, this understood that this is a calculation task. And this has redirected the question to the calculator. And the calculator has got this as a response, in which the operation is supposed to be add, and the arguments are add A is 5, B is equal to 3. And then iteratively, because there is a third argument, it again goes back and then says 5 plus 3 is equal to 8, 8 plus 2 is equal to 10. And then it got the answer back from the calculator, and then it shows us 10 is the result. So this is an example of a successfully running a locally powered Llama agent. So now, you know that it actually works. Let's start from the first. What we are doing here is that we are actually building our own Llama agent. So for that, we need to have certain items completely updated. A Llama index core, Llama agents, Llama index embeddings, Hugging Face. These are certain things that you need to have absolutely ready at this point for this to completely work. I've got a separate tutorial about Llama index using Ollama. I'll link that in the YouTube description if you want to try it out. So you need to have Ollama installed. You need to have Llama agents installed, updated, latest. After you do that, we're going to set up a simple Python logging for us to understand what kind of messages are happening. This is very important for us to understand what is happening behind the scenes. The next thing is, because I'm running this on Visual Studio Code Notebook, I'm just enabling the async IO. If you are running this as a Python script, you don't have to probably enable this. The next thing is, from Llama agents, we are importing agent service, agent orchestrator, control plane server, local launcher, simple message queue. If you're not very familiar with these individual things, I would strongly encourage you to watch my first Llama agent video where I've briefly touched upon these points. The next important thing is we're going to create a React agent. Typically, people create a function calling agent worker, but Llama index actually filters models based on the model's function calling capability. And even though your model has good function calling capability, Llama index would actually say for every local model that this model is not good for function calling, so will not let you run. So because of that, we are actually creating a React agent. This is a system in which the LLM goes through a thought or thinking process, and then it gives an answer back, then it thinks again, it gives an answer back. So if you're not familiar with React, again, this is a totally different concept, but just you know that this is a React agent. Then we have a function tool to create to take a function and create it as a function tool. Then we have Ollama, because we have to access Ollama models. This is just simply settings to enable LLM, and because sometimes we need local embeddings to access the local memory, we are also going to use the Hugging Face embedding. So all these things are going to be done locally after you've successfully installed the Python libraries. So this is all the import statement that we need. The main thing is Llama agents, and also you need a Llama index core, which from where you get the function tool, React agent, and then you have got the Ollama model with which we will define our large language model. Now that we have done all the imports, now we have to define the two tools that we discussed at the start of this video. A calculator tool and also an NLP tool, a very basic NLP tool. The calculator tool is, it has three arguments. The first one, it takes operation as an argument. If float, operation is string. Then another one is A, float, B, float, and it returns a string. So it takes three inputs, returns a string. And what does it do? Performs a basic arithmetic operations. You add the details about the arguments, and the result of the operation as a string will be returned. Now what is it? It is, if operation is add, then it is going to add. If operation is subtract, it is going to subtract. If operation is multiply, it is going to multiply. Operation is divide, it is going to divide. But before dividing, it is also going to validate whether it can divide by 0 or not. And then finally, if there is an invalid operation other than these four basic calculations, it is going to say the operation is invalid, and finally it is going to result the result, and then it is going to give the output as a result. So this is our calculator. So after we have defined our calculator, let us define the second tool that we are going to use in this multi-agent system, which in this case is a text analyzer. It takes a string as an input, a string as an output, performs basic text analysis, arguments is text to analyze, returns the analysis results as string. So now what does it do? It does word count, character count, sentence count. That's it. That's all it does. Not a sophisticated NLP tool, but basic one. And again, couple of try and catch here. So just to make sure that, we are not going to fall into any kind of bugs that we have not handled. So now from the functions that you created, the function of calculator and the function of text analyzer, you're going to create the tools. So function tool dot from defaults, the function is calculator, and function tool dot from defaults, a function is text analyzer. The first tool is going to be called calculator tool. The second tool is going to be called text tool. So now at this point, we have the two tools ready. So these tools have to be mapped with agents, and then we can start playing around with that. Now we're going to define an LLM. So we're going to use Ollama, define the model Mistral. For this to work, you should have already had Mistral locally in your computer. One of the easiest way for you to verify that is you can actually go to your command prompt, and then you can say Ollama list. Once you say Ollama list, you will get an idea about what are the models that are available locally in your computer. So for example, in my case, I've got Mistral, which I'm going to use in this video. I've got Llama 3, which probably I can also use. And then the other models that we have got, all the other models like Arcee Agent is available. So this is important for you to ensure that these models are already downloaded in your computer. If it is not downloaded, all you have to do is Ollama pull 5.3. Like this, you can just say it will start downloading the model, whatever model that you want to use. Once that is done, so you have successfully specified what is the LLM that you want to use. And here you have also mentioned the LLM settings. Just saying that LLM, whenever you define LLM is what LLM is. Now you're going to define two agents. Like I said, this is not a function calling agent, because function calling agent does not work at this moment with Llama Index with local models, Ollama models. So we're going to define two React agents. The first React agent uses a calculator as a tool. So this argument, as far as I know, is tools, I guess. Let's see. Hopefully. Yeah. So this one is tool. The second one is LLM. Verbose is to say whether you want to actually see these messages, verbose messages. So the second agent, we are going to define, the first agent is agent 1. The second agent is agent 2. I could have probably given better names. And the second agent is going to have text tool. And in this case, I'm going to use Arcee agent as a model. And during the course of the video, I'm going to also, play with this and then show you how the output changes. Like I said, this is not a robust system yet, but I wanted to put this word out there so that you guys can play with this model, local models, and then see how useful it is, how efficiently you can build your local multi-agent system. So now we have got agent 1 and agent 2. And agent 1 uses the same LLM like Mistral. The second one uses Arcee agent as an agent. One of the reason I went with Arcee agent here also because this is an NLP tool. I didn't want a lot of issues. But again, I wouldn't say in this particular case, it's suited very well, but it does its job. Then we have got the embeddings model in this case, which is a very small BG embedding. And after we have that, we have to define the 4 important things. We need a message queue. That is how the message is being transmitted. So for example, if there is a question from the user question goes to the message queue, And from that, it also goes to the control panel. Control panel's message comes back to message queue. So the message queue is like a pipeline, very important part. And if you're familiar with the designing software systems, it's what people do with all these AWS systems like Kafka and all the other things. So you've got a message queue. Then you have got a control plane server. So that takes the message queue, and there is an orchestrator, an agent orchestrator, an LLM that handles things. That is a control plane. Then we design our first agent service. The first agent service takes the first agent, takes message queue, and has a description about what the agent is. Okay, useful for performing basic arithmetic operations like calculations. Service name, calculator agent, port in which it is going to run, 8002. If you are not familiar, a Llama agent, every bit of a Llama agent is a microservice. So this enables you to deploy it across machines, a distributed deployment, and also it gives you the microservice architecture that software engineers sometimes love, sometimes hate. So the first agent, agent server 1, has got agent 1, the message queue, the same message queue, the description, the service name. The second agent server 2 has got the second agent, the message queue, and the description useful for performing NLP, text analysis, text processing, and the service name is NLP agent. Now, there is a launcher, the local launcher, so you can launch it two different ways. One, you can use a local launcher and launch, or you can also use a server launcher. In my case, in this current tutorial, at least I'm not doing the server launcher. I'm going to just go ahead with local launcher. Once you launch it as a server launcher, everything has to be a microservice call. So like this, I cannot make this call and get the answer. I have to send it to the control plane, I guess, and get the response back as an HTTP request. So to avoid that, I'm just going to launch it as a local launcher. In local launcher, we have got two agents, agent 1 and agent 2, or agent server 1, agent server 2, the control plane and the message queue. The launcher is ready. Now all you're going to do is launcher.launch single and then ask the question, what is 5 plus 3 plus 2? Let's maybe ask a different question. 10 plus 3 plus 2. I'm going to run this. Let's see if it works fine. One of the problem with the React agent is if the model is not very good, model is not very accustomed to React prompting, it might go in loops, and that is one of the things that you could see happening during the course of the video. Because it goes in loops, it finally does not end it. Sometimes we have to stop it and then see. And you would also see something very interesting, and honestly speaking, I would like to show you that. For example, first we send the message. So because we are logging info, a calculator agent has been registered, an NLP agent has been registered, a human has been registered. Thank you for acknowledging me, Llama Agents. I really appreciate you. A control plane has been registered. So the calculator agent is launch local and the NLP agent is launch local. So this is all in message queues. You can see here. And there is a service agent, the service agent. Now the message queue has got a new message. So publishing message to control plane with a new action, new task. So the action is new task. So you're just telling the control plane that there is a new task. Now launching message queue locally, publishing the message to calculator agent with the action new task. At this point, it has figured out that the task that we gave is a calculation task. So the calculator agent is the right agent for this. So it is publishing the message to the calculator agent with the new task. Now the message has been published, creating a new task and successfully published message calculator agent to consumer. So what is it? So there is a thought. The thought is the current language of the user is English. I need to use a tool to help me answer the question. And do I have a tool? I already have a tool. What is the tool? The tool is calculator. So what is the action input? It took the prompt that we gave and then converted into like a function call. In this case, it has got operation, which is add, and the values are A, 10, B, 3. So what have we given here? 10 plus 3 plus 2. So 10 plus 3 is 13, and technically 13 plus 2 is 15. But in this case, the React agent did not do that again. As you can see here, it did not do here. So it just came out of the React and then it went to the second LLM, which says, I can answer this question without any tools. I'll use the user's language to answer. 10 plus 3 is equal to 13, and it made a mistake. It did not work. Now let's ask a different question in this case. So I'm going to just say, analyze the text. Hey, how are you? Let's send this. sometimes during my trial, I've also found that, when you tell it to stop after getting the right answer, you would actually see sometimes it is stopping, but sometimes it just goes on loop. So now what is going to happen? So as you can see here, we have calculator agent and NLP agent. We have a new message that has been posted to the control plane, but now the message goes to the NLP agent because it figured out that this is an NLP task. It has to go to the NLP agent, and NLP agent has been summoned with the new task. And once again, our message has been successfully turned into a JSON response or a function call. In this case, the input is text, hey, how are you? And the text analysis result is we have got 4 words, 1, 2, 3, 4. Number of characters, approximate sentence count is this. But once again, like I said, because the React agent is not very accustomed to what we are doing here, it goes on in loop. As you can see here, it has gone in loop, and it finally has assumed that it does not have an answer, even though at some point in the middle, it has figured out the answer. Like I said, this is not a perfectly working solution, and you can see where the problem is. Couple of things that you can change. You can try to use a different LLM and then see. And also you can have a certain more templated approach to the prompt, and then you can see if it actually works. One more thing that I'm going to do different this time is I'm going to show you how I'm going to interchange the LLMs and then see if there is any difference in the answer. So for example, instead of using the Arcee agent as agent 2 model, I'm going to use Arcee agent as literally the LLM. So I'm going to just go here, just use this as a Mistral. Okay, let me go here, Mistral, and I'm going to use Arcee agent as an LLM for agent 1 and also Arcee agent as an LLM for the control plane. So I'm going to just select the LLM Arcee agent, agent 1, right? And we have everything set at this point. Let me just quickly check. We have the control plane with the agent orchestrator, and the LLM is here. And again, it lets you change LLMs here. So for example, here I can have a different LLM. For agent 1, I could have a different LLM. For agent 2, I could have a different LLM. And this being a microservice further makes it more granular in what kind of things you can control. I'm going to run this with the same question, not a different question, exactly the same question. And the first win comes in when it actually rightly identifies the task and sends it to the right agent. And as you can see here, it is still figuring out. And in this case, Arcee agent is slightly heavier than in my machine at least. Arcee agent is a 5 GB model. So you can see my Arcee agent is a 5 GB model, and Llama 3 is 4.7 and Mistral is 4.1. So Arcee agent naturally takes more time here. So it correctly identified the message was routed to the right agent. But again, once again, as you can see here, it just goes on a loop, which is something that we need to work out with certain prompt engineering, or we'll figure out what to do with this. So this is one thing. I'm going to stop it at this point. Okay, it has already given me the answer. So I'm going to just ask now a calculator question. So let me go again and ask, can you divide 100 by 20 maybe? This is the easiest division calculation. 100 by 20 is 5. Yes, 5. Once again, there is a new message. The message has been posted to calculator agent. So the job has been done. And it says I can answer without any tool. Oh, it's overconfident. But it did a good job of giving the answer. But again, the whole point of this is for it to answer with the tool. This is again the problem with the React agent. So I hope when we use function agent, this issue should not exist. But anyways, in this particular case, I can answer without any tool. I'll use the user's language to answer, and dividing 100 by 20 results in 5.0. So we got the successfully correct answer. And at this point, this is a lot more prototypish, a lot of experiments. I'm also learning a lot of different things, how to influence the result. And Llama agents being new, I thought like this is a great time to put out this message out and then see how people are using it. And I also wanted to try slightly more sophisticated functions. Right now, I wanted to make a simple tutorial explaining the entire skeleton where the function does not call an API in itself. So as you can see here, my current functions are just like literally functions. But in the future, I want to create tools that can call external APIs and then see how this thing can actually efficiently work. And also I want to make like a server launch and then see how we can have like different services and communicate with this. These are certain things that I've planned, but if you have any question, let me know in the comment section. Otherwise, this notebook will be in the YouTube description for you to try it out. Let me know what do you think about this new Llama Agent series. I'm quite excited about this. See you in another video. Happy prompting.